So thanks for coming along, everyone. So just to kick off a bit about me, I'm Jamie MacDonald, and I'm the head of security at Rasa. Rasa build a conversational AI platform, which basically means we build kind of the infrastructure layer that people build chatbots and virtual AI assistants, things like that on top of. So my team works on both the security of the organisation itself and also application security, since some of our enterprise customers have quite stringent requirements for like security and compliance as well. Previously, I worked at Fortinet and ZoneFox doing security engineering. So my talk today is about building a security function at a company, and it's from the point of view of a kind of high-growth startup with a big engineering function that builds a product, because that's what my background is, and it's kind of one of the most challenging places to insert a security culture. This is a shameless attempt to warm up the crowd with a picture of cats, my cats, before I get into the main body of the talk. Hopefully that works. So to start with, we'll take a quick run through the kind of business aspects you need to consider if you're in a role either as the only security person in a business, or if you're in a role where you're kind of the head of security, you're starting off a team. The business stuff is just as, if not more important than all the technical stuff, because that's what keeps you on the right track and keeps you aligned with what the business actually wants you to be doing. And then the second part, I'll move on to the practical bit. So these are actual concrete things that you can implement and kind of the key themes that you're looking to achieve. I'll give some examples of tools that you might want to use as well. They're not endorsements of these tools. It's just kind of examples of things that you might be wanting to use. And all of this is aimed at the kind of context of quite a small company, quite a lean team, where you're kind of in a high-growth environment and a lot is changing and you need to get a lot of stuff done. So bear that in mind, that this is not also going to necessarily be correct if you're in like a big business or an enterprise kind of scale, because different contexts need different approaches to it. So to kick off the business stuff, I'm going to introduce some hard truths to bear in mind that will help kind of ground you and help kind of align you to what the business is wanting you to do as you kick off. It might seem a little bit harsh, but hopefully it'll make sense as we go through the rest of the content. Nobody cares about security. So this is the hardest one to accept for most people here, because folk here are going to be genuinely passionate about it, and you probably all wish that people would take it more seriously. In reality, people do take it seriously, people know it's important, but if it gets in the way of them doing their job and it inconveniences them, they will try and strip it out or work around it to make their lives easier. So your job as a security person in a business is to facilitate people being able to go about their jobs in a secure way. Ideally in a way where they don't even notice, because you've made it so seamless and so painless. The point of the business is not security. Now, the only place this doesn't apply is if you actually work for a security company or a vendor. But for the vast majority of organisations, security is not the point of the business. So day to day, it's not really anybody's number one concern apart from yours. And this one's really important to remember, because kind of projecting a sense that security is the most important team in the business is just going to make nobody want to work with you. You're not there to say no. This is a really important one. So unless the company you join is made up of people who are fresh graduates and they've never worked anywhere else before, people are going to have preconceptions about what a security team in a business is. And almost certainly that preconception is going to be that you're the team that tells them that they can't do stuff. So remember my last point. You're there to enable the business to work securely. In the vast majority of cases, you'll be able to work out a way that people can do the tasks that they want to be doing securely. If you just say no to everything to try and eliminate as much risk as possible, people are just going to go behind your back and do it anyway. They're not going to stop doing it. They're just going to stop telling you that they're doing these things. And in almost every case, your job isn't to prevent people doing things. It's to work out a way that they can do the things they want to be doing securely and in a safe way. So work with people and not against them. The final one is crucially important as well. End users aren't stupid, and you shouldn't treat them like they are, because they'll really resent that. They might not know as much about security as you. They might do things that give you anxiety, but protecting them and enabling them to work in a secure way is why you're there in the first place. And so much of the groundwork for building a security program is about establishing the relationships with people. And if you just crash in and tell them that you know better, it's not going to make you any friends at all, and it's going to make your job a lot harder. So once you've accepted all that, the first thing you need to do is work out where you fit within the business that you're part of. So if you're lucky enough to be in an organisation that really does care about security, other than one that just sees it as a tick box or formality, this is going to be a lot easier. Now, the goal here is basically to work out what the business or the exec team or whoever's in charge actually think that you're here to do. Because once you understand what their priorities are, you can then work out what security measures or controls help support those aims. And that's the best way to start, because if you kick off by solving existing problems that people in the business have, it's really obvious that you're providing value and doing a good job. And this is arguably the most important part of starting off your program as well, because this is where you engage with people to find out what the problems are, and you make friends that will help you further down the line. And it's really important to start off by being the team that solves problems for people, rather than the team that enforces controls and makes people's jobs harder. So part of this is working out your business's threat model and your risk profile. So if you go into a small org where the main concern is phishing or password security, don't start off with reverse engineering malware you found and assuming that they need to defend themselves against like nation-state APTs. It's going to be fun, for sure, but you're not going to last very long because you haven't understood the problems and the concerns of the business that they are paying you to mitigate and solve. So make sure that you start off at the level the business is already at. For a lot of organisations, that does mean that you're going to be kind of hand-holding them through rudimentary basics as first steps. But the first steps are what you need to begin with to be able to build towards a mature security posture. So this brings us to the foundations of actually starting your program, of which there's kind of 4 key areas: communication, tools, processes, and your team. So the idea of communication is to be approachable. Make sure other teams know what you can help with, what you're there for. And I can't stress enough that other teams need to see you as a helpful team rather than one who hinders your progress. And if you can achieve that early on, it makes everything else that you're going to do a lot easier. You're going to need some standard processes and playbooks that define how security works for you. It might sound like a very kind of enterprise way to start off, but it doesn't have to be. Your company's InfoSec policy could literally just be a single side of A4 if you wanted. You're obviously going to need tools to help you out, but it doesn't necessarily mean you need to spend hundreds of thousands on big vendors. A lot of what you need can be found open source or done on a budget, and I'll talk a bit later about what kind of tools you might want to look at deploying. And last but not least is a team. You're not necessarily, in fact, you're probably not going to end up with a huge team. You might not end up with any team. It might just be you. But kind of knowing what skill sets are available and how they could help with the things that you're going to work on is really important. And there are more kind of roles and specializations within security that most people realize, especially as you're kind of starting out your career. So I'm not sure how well this is shown up for the people at the back. But this is a really good illustration of just kind of how varied and extensive the areas of responsibility within security are. If you're going to be leading a security function, you need to be aware of all these. You don't need to know them all, you don't need to be an expert in them all, but you need to know that these things exist, so that when it comes time that you need something from one of these other areas, or you can recognize the kind of the points where these things start to become important or relevant. I'm not going to go over this whole diagram in depth because that's going to take up the whole hour. But once you understand the environment that your business is operating in and what the security needs are, look back at this and kind of it will be more obvious as to what areas you can kind of pick out as the key priorities and the places that you need to focus on first. In general, I'd suggest that a lot of the kind of enterprise risk management and governance stuff down at the bottom right is not a great way to start off. It quickly becomes a kind of really bureaucratic time sink, and you deliver more value more quickly by focusing on things like access control and 2FA. But overall, in a situation where you're kind of just starting off your program, if you're going to grow your team, you want to try and find a really good security generalist to help you, who can focus on any of these tasks based on kind of the priorities of the business, security engineering, security ops, those sorts of areas. And that will help you focus on the first task, which is securing the organization. Because if you're an organization that builds a product, an insecure organization cannot ship a secure product. So you need to focus on the organization first. So we've got some idea of the kind of business environment that you'll be operating in now. And it's always worth bearing this in mind, because thinking about what you're doing in the context of the business is going to make you a more valuable employee, and you're going to find that it makes it easier for you to make progress through your career. So I'm going to move on to the practical side of actually implementing the program now as well. So your security roadmap is a kind of long-term vision of where you see the security posture of your company going long-term and how you expect to get there. So for the kind of company I'm talking about, which is a kind of large engineering team, you ship a product to customers, I split it into 3 broad themes, and you can categorize most kind of initiatives and controls under these. And they are the organization, product, and the infrastructure. So the org pillar covers things that affect all the staff and act across all the business. So this is things like policies, processes, password managers, and actually kind of establishing the security culture for the business as well. The product pillar covers all aspects of security that relate directly to the product that you build. So this is things like application security, tooling for developers, and code scanning. And then the infrastructure pillar covers any kind of on-prem equipment that you might have, cloud services, making sure that you're aware of your overall attack surface and that you're monitoring it as well. And breaking the initiatives down like this can help you plan and prioritize what's required to build your security program. So for the rest of the talk, I'm going to discuss the kind of things you might want to put in your roadmap, and then we'll wrap up with what you should do with your finished roadmap and how to proceed on from there. I'm going to start with policies and processes because it's the most boring one. And I know for certain that a lot of people here are going to think that it's kind of a thing you only need to care about if you work for a big bank, but it's unfortunately not the case. So you need to be aware of this for companies of all sizes. It's not just an enterprise thing. And if your company sells to other businesses, you'll really quickly find out that these things are just non-negotiable, and that you have to answer security questions about your products and your processes. And if you have docs and policies that you can pull out to answer these questions, it makes things much smoother and much more seamless. So what kind of policies do you actually need to start with? At a minimum, you want to have a kind of general InfoSec policy that basically defines what you expect and require from your employees. So this could be things like using 2FA, enforcing disk encryption on devices, password managers, things like that. And this should be a readable document. It shouldn't be long, it shouldn't be in legalese, it should be straightforward and simple for people to understand. You're also probably going to want some kind of data protection policy that outlines like the kind of controls that you have to protect data, the fact that you use least privilege controls to manage data access and things like that. Require encryption for personal data, and who to go to if there's a problem or a data breach. And when you're working out which of these policies you need and which ones to work on first, one of the first things you should consider is if your business has to comply with any kind of compliance regimes like GDPR and things like that. Now, this depends on what you do and what kind of data that you process, but it's a really good way to direct your attention to kind of the most important and impactful things to work on first. If you don't need to comply with anything specific, think about maybe your customers that you're selling things onto do. If you're selling to any other business, they're going to want to know how you comply with GDPR. Even if you don't think it's relevant, even if you think it's interesting, not that interesting, you have to have documentation that explains how you deal with this because they need that to be able to pass on to their customers. It's really difficult to sell products to other businesses now without having shown that you've thought about privacy, you've thought about data protection, data security. And if you're able to answer sales questions with things like, yeah, we've got a policy for that, here it is, it's much easier and it just makes things go a lot quicker. But also, don't go nuts with it. You don't need policies to cover every possible scenario or every possible compliance regime. The aim of the policies are to make things easier and to be useful and help with answering people's questions, not to kind of drown you in pointless paperwork and bureaucracy. So, now that you know what policies do you need, how do you actually start writing them? Because that seems like quite an overwhelming thing to have to do to begin with, and how much detail do you put in? Luckily, there's a bunch of frameworks and industry bodies that can help with that. So there's NIST, who are an American government body. They publish a huge amount of documentation and standards on building security programs and even kind of down to technical controls like encryption specifications and the kind of thing you should use. There is SANS, who most people here will probably have heard of, a training body, and they provide a lot of sample templates that are kind of just like basic boilerplate that you can slap your company name on and you can make little tweaks here and there to match the context that you're in. There's Cyber Essentials. Now, this is a UK government effort. Who's heard of Cyber Essentials before? Okay, most people. So it's not policies in itself, but the controls that they recommend and require are a really good way for you to kind of direct what you want to focus on first, because these are kind of the main things that other companies will be looking for. CIS benchmarks, again, they're not policies as such, but they're kind of like the authoritative standards on controls and configurations for basically any kind of system you can imagine. Operating systems, cloud providers, that define kind of the controls you should have, the configuration you should have for best practices. And again, use these benchmarks to inform the technical content of the policies that you write. And also GitLab. So their stuff can be really useful when you're working out what they need. Because GitLab publish online publicly all of their internal policies, their employee handbook, everything, and they have a really mature security posture. So it's really easy to kind of see where you want to end up by using some of their content to help inform the kind of things that you're writing as well. And you can write them from scratch if you want, but it's difficult to know where to begin. So I'd kind of recommend just starting off with a sample one that someone else has written, like the SANS ones, and just making little tweaks to suit your business and the controls that you want to introduce. I'm going to mention a lot of tools in the rest of my slides, but first a little bit about how you could go about picking any of these tools that you might have on your radar. So this is a controversial one, and it's specifically aimed at the kind of startup or scale-up environment where you don't have a lot of time, you don't have a lot of people to help maintain things. So wherever possible, if you're buying security tooling, prefer options that are SaaS or managed by a vendor. And the main reason for this is that if you're self-hosting an important tool, there's now loads of other costs associated with that weren't immediately obvious necessarily, which I'll go over in a second. But at a high level, the main reason that you're employed is to provide value to the business, right? Your value with the tool comes with your ability to operate and interpret the results and the alerts and act on things from that tool. It doesn't come from adding another system that you have to patch and maintain and back up and things like that, because that's not what you're there for. One tip for the process here is when you're speaking to vendors, ask if they have other security documentation or compliance certs or pen test reports and things that they'll only disclose to you with a non-disclosure agreement. So most companies will have kind of the security and privacy page on their website. There's nothing exciting there usually. The juicy stuff is the one that you have to sign the NDA for to be able to see. They won't announce that to you probably, but if you ask for it, they're usually more than happy to give you this kind of stuff. And that gives you a really good idea as to what their internal security posture is like, and it gives you an idea how they look for vulnerabilities and issues and how they resolve them as well. A vendor who can't give you information like that is a bit of a red flag. So when I say use SaaS, I mean like use it safely. Don't just buy anything that you can find because someone else is running it for you. And I also want to quickly go into some of the things that are kind of often overlooked when you're working out whether to go with SaaS or whether you're going to self-host a tool. And explain a little bit more about why I lean towards the idea of SaaS being the way to go for your growing business with quite a kind of lean team for operating things. So when you've done your initial comparison, you've probably looked at the slightly cheaper license fee and the cost of running a VM on a cloud provider, and you're like, that's how much it would cost us to self-host it. But it's not really as simple as that. There's a whole bunch of other things you need to factor in that the vendor is probably, or a competent vendor is probably running for you transparently to you as part of the SaaS service. So there's a few things you need to think about. Your time, which is, as a security person, expensive. Patching the OS, patching the product itself, ensuring that everything's up to date. Backing up any data that it has, scheduling it, the extra storage costs that come from that, checking whether they're working or not. Reliability and uptime. If the SaaS version runs across like multiple AWS regions and there's failover and things like that, and you're running it on an old PC in a cupboard, you're not comparing like for like there. That's not the same thing. If the app collects lots of data, do you need to manage load balancing or things like SSL termination? Are they doing things for you like web application firewall or DDoS prevention? And then finally, think about how the environment you would deploy it into actually compares to the SaaS vendors. So if you're deploying a security tool, where integrity of the data is important, if you're going to deploy that into a cloud account that's shared with a bunch of developers where they would have access to that tool, that's not really that great. So these are just a few examples, but my main point, your time's valuable, and you should consider whether self-hosting something is really the right choice for you, and whether you can do it well enough for the purpose of the tool. So one of the first things that you should consider introducing is a password manager. I don't think I need to sell the benefits of a password manager to anybody here, but you might have to sell it to the people with the money in your company, especially if the concept's new to them. So one way to approach this is to focus on how it helps the business, because that's what they really want to know about. An executive with budget, they don't care about the intricacies of credential stuffing, right? They just don't. But they do understand the concept of reducing risk for the business. So if you can find kind of recent or relevant examples around like data breaches or attacks where the entry point was poor quality or reused credentials, that's really helpful to support your case. Same with stats around phishing, since password managers reduce the chances of a successful phish by only kind of auto-filling credentials on sites with the right domain. You've also got to pick one. So there's a few criteria that you should look for here. It needs to be easy for all of the staff to use, not just techies. Some weird self-hosted KeyPass install that syncs with Dropbox isn't usable for non-technical staff, and it's a really bad way to start. It should make it easy to share secrets between employees, which might seem counterintuitive, but people are going to do this anyway. And if you don't provide a secure way for them to do it, they're going to use things like email or Slack or text messages instead. And finally, the company that you go with should publish a lot of documentation that goes into significant detail about how their security works, how they secure their infrastructure, how they implement things, and how they review it. So 1Password, for example, they have a white paper that's 100 pages long that details their infrastructure security, how they manage keys and cryptography, and it's a fascinating read. It's an insane amount of detail, and it helps you kind of appreciate the security posture that goes into these things and verify whether that's enough for the kind of data that you're putting into it. It's also worth considering if there's any secondary benefits to a password manager. So the largest vendors, people like 1Password or LastPass, if you buy business accounts from them, they come with free personal accounts that you can then give your staff. And the benefit of that is that you are then showing your staff that you're not just caring about security for the business, you're giving them the capability to help secure themselves and help improve the online safety for their family as well, which can be a really good start to help kind of build out that security culture among your employees. Yeah.
You talk a lot about like whenever you're interfacing with vendors, reviewing their policies, just to assess like the level of readiness they have and like how seriously they're taking this. How much of what you ended up with at Rasa was informed by vendors even directed, this is really good way to structure this policy, or this is like a thing that I haven't considered. It sounds like quite useful as like just a tool for expanding your knowledge while looking through these tools.
Sure. So the question is, how much do kind of vendor policies and information from them inform the security controls at Rasa? And the answer is hugely. Yeah. This kind of thing is really beneficial because you're seeing how security works at other companies, and you can steal all their good ideas and incorporate them into what you're doing. It's a really good source of kind of knowledge and information about how successful and large security enterprises run stuff. And if you can cherry pick ideas from them, absolutely take that and apply. So hot on the heels of password managers, single sign-on. The idea here is that you only have one system where you manage all your users, and then your tools kind of integrate with this to authenticate users to it. It's really useful because it makes onboarding and offboarding users much easier, because you only have a single source of truth for who's employed, and you only have one place to remove users from when they leave. You might already have access to an identity provider without realizing it. If you pay for Google Workspace or G Suite or whatever it's called this week, that can function as one. If you have Azure or AWS accounts, there's stuff built in there as well. It's not always something that you have to pay another vendor for. You might already have this without realizing it. Another kind of more niche benefit is that you can use single sign-on to strengthen the security posture of other third-party tools that you integrate with. There's quite a few tools out there that support single sign-on integration, but they don't natively support their own 2FA. So if you can restrict sign into those apps to your single sign-on tool, you've kind of brought with you the 2FA benefits from your identity provider over to this other tool that didn't support it. So this all sounds great. It is. You should use it wherever you can, but kind of accept that not all tools or third-party services are going to offer it, so you're probably going to need a password manager as well. But there's one major flaw with single sign-on, and that's usually whether or not you can actually afford it. The provider isn't usually expensive, and we've just discussed you might already have one without realising it. But paying for single sign-on support within your tools themselves is often very expensive. So this is a screenshot from a website called sso.tax, which collects examples of vendors that are charging particularly ludicrous amounts for single sign-on support as part of their kind of enterprise package. They do this because they can, and they get away with it. Vendors know that big companies where SSO is kind of mandated will pay whatever they ask to be able to meet those requirements. So while you should use single sign-on wherever you can, there will be some places, especially if you're a small company or a startup, where it just doesn't make the financial sense to upgrade to a plan that will allow you to. I think the most egregious example is HubSpot, who have a 6,300% markup between their normal user tier and the first tier that allows you to integrate single sign-on, which is just crazy. Another thing I don't need to convince anyone of here is the value of 2FA, but you should, as a kind of admin for apps across your business, enforce it wherever you can. As I mentioned earlier, even if a service doesn't natively enforce it, see if there's other ways that you can enable it, like integrating with single sign-on. And at risk of starting another classic InfoSec Twitter flame war, any 2FA is better than no 2FA, right? So you can get upset about SMS 2FA as much as you like, because it's not perfect, but it's better than not having any 2FA at all. You shouldn't pick it over other methods, but it's better than not having anything at all. And you should always use the strongest method that's available to you. So here's a kind of spectrum of how secure an authentication mechanism is, from kind of least secure at the bottom up to most secure at the top. And I'm pretty sure that it's not going to be legible past like the first 3 rows. You're going to have to take my word for it. So this is a really valuable graphic. Not only does it give you a kind of unambiguous ordering of what methods are strongest, it also lays out what each of those methods are vulnerable to in terms of the kind of attacks that can work against them. I've added the triangle on the right that kind of illustrates the volume of attacks as well. So the higher you progress on this maturity model, the fewer automated attacks you're going to have that can be successful against you, and the fewer adversaries that are going to be out there that actually have the capability to take on controls like that. And as I mentioned earlier, this helps you work out what's suitable for your threat model in the context that you're in. So the best option would be right at the top. Hardware-backed passwordless authentication. But if your company's right down here at the bottom, and you're still on kind of stage 2 or maybe even stage 3, it's a big leap to get everybody right up to the top in one go. And improving the maturity of security across your organization is a journey, and you have to make sure that you bring everybody with you as well. You can't just kind of one-up other teams and leave folk behind. So based on that, it's okay to make incremental improvements. And if you can do that quicker than waiting to make a big change, it's worth doing. So if you can enable SMS 2FA for stuff, that's an incremental improvement. You shouldn't wait until everybody's got YubiKeys to be able to do stuff like this. Make incremental improvements wherever you can, because they're still beneficial. So carrying on from the theme of 2FA, I want to specifically touch on hardware security keys. Most of the keys that you'll see are made by Yubico, but other manufacturers are available. There's a lot you can do with them, but there's kind of a few main themes as to why you might want to roll them out. They're basically the gold standard for authentication at this point. Some of you might have used them before. When you're prompted for 2FA, you tap the little gold dot on the key, and that's you authenticated. The process that's going on under the hood there is actually really sophisticated, more so than people might realise. You can't phish or man-in-the-middle credentials for a site that's using these keys with a modern algorithm like WebAuthn or something like that. And for these sites, the authentication is pretty substantial under the hood, but it's done in a way that is kind of transparent to the user, and you make things easier for the user whilst also making things more secure. So for sites like this, the site authenticates you with the key, but the key authenticates the site at the same time as well, with a special handshake, which eliminates whole classes of attack. So not only is there a second factor, but it can't be phished, and it can't be stolen like a kind of 6-digit code for an app, from an app or a text, and used kind of out of band without your knowledge. The key physically has to be involved in that transaction to be able to authenticate. You can use some different functionality on these keys as well. You can use them for SSH authentication, or you can use them for signing Git commits by your developers to show that once a commit has been made to your product repo, that developer physically had possession of that key, which proves that it was them who made that commit. And that's a way to kind of help reduce the impact of the likelihood of like supply chain attacks or stolen Git credentials being used to put things into your product. And you should consider starting this by rolling them out to your highest risk users, which is people like admins, and it's also your exec team. Once you've got them kind of rolled out to everyone, you can start to slowly enforce their usage across systems until everything gets covered by strong hardware-backed authentication. Enforcing them on your single sign-on provider alone is a big win, because that should then impact multiple products and accounts as well. Lastly, at the org level, I want to talk about device management, kind of for all like the laptops that you hand out to employees as well. So some small companies don't roll out device management right at the start, thinking there's only a few devices, so it's not that important. But in reality, this is the easiest time to roll it out and kind of secure the devices that you have and establish like a baseline configuration that you know works across them all. You can't secure the assets and devices that you don't know about. So making sure you have kind of a single console where you can view the status and the configuration of all your devices is really valuable. So there's a few benefits to that. Like I said, you easily enforce baseline security controls across all your devices. So things like disk encryption. You can then see if devices have deviated from that and map the policies that you wrote right at the start onto the controls that you then apply across all your devices. You can enable automated software patching across all your devices, which is such a basic security win that's often kind of overlooked. But combining this with MDM software that kind of inventories everything that's on all your devices gives you a really powerful tool, because then if a new software vulnerability comes out, you can check very, very quickly which of your users are affected and if any of them need to be patched. Also, it lets you lock or erase devices that get lost, which is especially useful if you have staff or execs that are traveling a lot. It also sounds like a thing that would be expensive, but it's actually not, weirdly. A basic kind of cloud-based MDM platform that lets you update things and apply controls to devices is usually like a few pounds per device per month. It's really not an expensive thing to roll out. So, I'm going to move on to securing the product that you're building now. The obvious place to start for this would presumably be a pen test. Seems sensible, lets you inventory all the issues that you might be having with the product and crack on with solving them. But if the pen test is the first interaction you have with the engineering team, it's not really a great idea. It's not the best idea, unless you have an urgent business need for one, like a customer who isn't going to buy your product until they get a report on this stuff. Now, that might seem counterintuitive, but the reason for that is that if you're new and you come into a dev team and you slap down a report of vulnerabilities, some of them are going to take that personally. Some of them are going to see you as the person who doesn't know the background or doesn't know what they've been up to and how hard they've working, coming in and telling them that they've done a bad job, they've introduced all these vulnerabilities, and if you do that, you're then going to find it really hard, and it's going to take a lot longer to kind of rebuild that trust and get the engineering team on your side. So instead, it's a much better strategy to kind of delay that for a couple of weeks or a few months to focus on building relationships with the engineers and showing them that you're there to help them. Find out what their security problems are. So maybe there's vulnerabilities that they think are issues, but they aren't getting the time to fix, that you could lend your voice to kind of help increase the priority of that. Maybe they're having security relevant problems that you can help to automate, like updating dependencies across code and things like that. And maybe they just don't have much background security knowledge. Providing kind of training and background knowledge for devs around secure coding and application vulnerabilities helps them connect what they're doing day to day with the impact of vulnerabilities that they could introduce. And making that link is really key for a lot of devs, and it will kind of help them click that what they are doing day to day has security impacts. And ideally, you make at least a few of them kind of more enthusiastic about security as well. And then once you've achieved that, a pen test changes from being perceived as a report about their failings to a report containing new challenges that they can work on, because they understand the context behind it, they understand the importance of fixing things, and the kind of motivation behind resolving them. As I mentioned earlier, you're going to need to provide some training to your devs, specifically focused around secure coding. The worst way you can do this is to give them just screeds and screeds of documentation for them to read. They like to code, so get them into practical activities and kind of gamified platforms as quickly as possible. So there's one called Secure Code Warrior, where you learn about application security by finding vulnerabilities in code snippets and fixing them and seeing how they can be exploited, and understanding the kind of end-to-end chain from them writing vulnerable code to it being exploited and there being like a data leak or something like that. And that kind of thing really helps people build that mental model where they see the effects and the kind of end impacts of their implementation choices. Most coding training focuses around the OWASP Top 10, which is a list of kind of the most commonly seen types of software vulnerabilities. This is a really good place to start, and you'll probably cover like 90-95% of the vulns in your application by teaching your devs the OWASP Top 10. Is that awesome?
Very easy because we get all the path.
Cool. Does anybody have an issue? Cool. All right. So OWASP produces cheat sheets that helps dev to kind of securely implement like common functionality like password storage or API security. And these are really valuable resources for devs to know about, because they're written to kind of to be aimed at devs. They're written in language they understand. They have code snippets and things through them. And once devs know about them and know that they exist and know that there's this kind of trusted location where they can have their security questions answered, they'll start to use them naturally. Finally, if you're not in a position where you can hire actual application security engineers for whatever reason, you can try starting a security champions program where basically each team or engineering squad has like a person with a particular interest in security, and they get a little bit more training and become like the subject matter expert to kind of disseminate security knowledge among the team, and also act as a point of contact who can escalate things if they spot security issues that could end up having an impact to you. You also want to have code security scanning done as part of your build process. It's not like a substitution for having a person do it or having a pen test, but it's like another layer to help catch more things before they end up in the product that you ship. Application security is a whole discipline in itself, but there's a few tips that are applicable kind of regardless of what your tech stack looks like or what stage you're at. Shift left is a phrase that you might have heard before. It's become a bit of a slogan for a lot of AppSec vendors. Essentially, what this means is that you need to shift scan results and security information as close to where devs write the code as possible. You need to kind of shorten the cycle between them writing code and getting security feedback on that to be as small as possible. And that means it's easier for them to kind of integrate fixes as they're writing, and they don't see it as like a kind of annoying chore that's tacked on right at the end. You want to have security embedded at every stage of the development lifecycle, but it's really crucial to get the actionable results delivered right to the devs as they're working as quickly as possible, as soon as you can after they've written the code. So this is why a lot of code scanning tools offer like extensions for IDEs or text editors that the developers use, and this is a really good way to introduce it, because literally as soon as they write the code, they can get feedback on whether that could have introduced security issues as well. Another thing you shouldn't do is enable a whole bunch of different security scanning tools that can like fail your build pipeline without having tuned them or looked at the kind of results that you're getting out of them. Devs hate this, and they'll just work around the scans and the results that you have and ignore the results because they don't see the value in them. So before you get to the point where some of your scanning tools should be able to fail builds and kind of get the code sent back to devs to fix, you want to make sure you've reviewed the kind of findings that it has and tuned it to make sure that they are sensible and they're valuable. Scanning also isn't just for source code. You get like linters and scanners for a whole bunch of other things too, like config files. Yandex make a scanner for Nginx, the web server, their config files that can identify like vulnerable configurations or common mistakes that you can write with these files that can then lead to exploitable vulnerabilities in your app. You can scan Docker files that kind of define the containers that you produce to deploy your product, and you can scan the images that are produced as well to kind of help you stick to best practices and identify if you're shipping any vulnerabilities in like OS packages or dependencies that aren't directly related to your product code. And finally, you want to automate as much of this as possible. It takes time to do, but the most desirable end state to get to is where all of these kind of things are automated and a dev is only involved if they really need to be. So for example, if you have a thing that's updating vulnerable dependencies and packages in your code, a dev doesn't need to do that. It's like changing a couple of numbers in a config file. Like, it's not a valuable use of their time. So instead, try and fix it automatically, run it through all your tests, and if something fails then and it hasn't worked, then a dev can step in and do it. But otherwise, the happy path is that a lot of these things can kind of be automated away. You get better security and your devs have less kind of boring tasks to work on. A nice segue between product and infrastructure is infrastructure as code, which kind of spans both. So if you played around with cloud stuff before, probably click through a web UI or maybe run some CLI commands and you've ended up creating specific infrastructure that you want. Now, the idea behind infrastructure as code is that you define the infrastructure you want, usually in something that looks kind of like a JSON or a YAML type file, and then a tool handles the deployment part for you to achieve that end state. It's a good idea for ops and security purposes, really. Firstly, it makes your infrastructure deployments repeatable and consistent, so it's really easy for you to spin up another environment if you want to do some testing or you want to audit things. Because they're code, you can now review infrastructure changes as part of like a normal code review process. But you're no longer asking people to review like big bash scripts that kind of eventually end up having some infrastructure deployed. You get them to review the desired end state, and the tool handles the deployment of that for you. So it's much easier to review because you're reviewing the what rather than the how. And because they're just code files, you can run security scanners against them. You could scan for like security best practices, or you can enforce your own rules like VMs shouldn't be deployed that don't have encrypted disks, or port 22 shouldn't be open to the internet, and things like that. And because you've defined that preferred end state, you can also use tools to enforce that in your deployment. So if you have maybe like a product that you've deployed, and a dev goes in and makes changes to how that deployment is done, you can have tooling that constantly inspects your deployed state and your desired state and undoes the changes that they've made to make sure that you always know exactly what configuration you have deployed. So onto infrastructure, and particularly cloud infrastructure, since that's where kind of most companies are heading. It's quite reasonable that you might end up working somewhere that only has cloud infrastructure, where all of their infrastructure is in public clouds. I'm going to focus on AWS, Azure, and Google Cloud, because that's probably what you're going to end up using. But don't forget about the kind of more niche clouds like DigitalOcean or Heroku or Oracle. First challenge is to work out what clouds you're actually using, which is harder than it sounds. A really good place to start for this is the finance team, or whoever pays the bills and does the invoices, because they'll be able to tell you what clouds your company is paying for and who's expensing them to help you find out who the account owners are and get access to them to secure them. Also, another tip is that if you've got quite a kind of sprawling cloud estate and you have a lot of accounts, account managers for the cloud provider like AWS can usually help you to find all of the accounts that are registered with like your works domain, and that will help you get a better view of what you have as well. Then once you're in, the best way to actually identify everything you have across all your regions and all your services is to use the billing functionality. Most providers make it quite hard to get like a full overview of all the infrastructure you have across different regions and things like that. So usually the only kind of true consistent place that you can find out everything you're using is in like the bill PDF, which could be like a 200-page PDF from AWS, but it at least lets you see kind of how much you're spending in what locations, and it lets you prioritize based on that. Another piece of really invaluable cloud tooling is Cloud Security Posture Management, or Cspm Tools. So these get connected to your cloud accounts and monitor the configuration of all your resources in accordance with like best practices. They can either be taken from standards like the CIS benchmarks that I mentioned right at the start, or they can be rules that you've defined for your own environment. And basically these give you a single dashboard where you can view exposure status and risks across all of your cloud accounts in one place. So they're really valuable. And some of the more advanced and usually expensive tools can also automate the remediation and fixing issues that they find as well. So you could say that across all of my AWS environments, port 22 for SSH should never be open to the internet. And you can have tooling that will wait to see one that is and immediately just close it again as well. So it's kind of like the infrastructure as code piece. As well as having Cspm tooling, you should take advantage of the cloud provider's own native security tooling as well. So while Cspm usually focuses on like configuration, the native tooling can focus on threat detection and runtime things through behavior, because they get visibility into metrics or logs or telemetry that's not kind of available to you or other products out with the cloud provider. So the types of tools I'm talking about are things like AWS Guard Duty or Security Command Center on Google Cloud. Depending on the cloud and what your estate looks like, they can be quite expensive, but they also provide a really valuable level of insight into what's happening in your environment, the kind of behavioral threat detection type piece. So these work by essentially processing and collating logs from all across your environment, DNS logs, user activity logs across the cloud provider, and hypervisor telemetry as well. And this gets fed in and it gets combined with IOCs from a whole bunch of security vendors usually. And the scale of data that these tools are processing across like all of a cloud provider's accounts means they're quite capable of detecting patterns that are affecting kind of distinct customers that you wouldn't see yourself if you were just looking at your own estate. And the volume of data they collect means their machine learning detections are usually quite accurate as well. So they do the kind of things you would expect. They can detect like malware, brute force attempts, or data exfiltration by looking at the network and the DNS logs for your VMs and things like that. But they can also employ some kind of other methods that are quite interesting and not something that you would be able to build yourself or using non-native tooling. So Guard Duty, for example, in AWS can monitor for API credentials that are created in your account but then used in another account somewhere else, which could be an indicator that there's kind of been some kind of credential theft and your credentials are being used by someone else. And Google Cloud, they announced the thing just on Monday. They built a way to use their threat detection tooling to detect cryptocurrency mining on a VM without having any presence on the VM or without actually looking at the network traffic or anything. It's purely by looking at hypervisor metrics, so kind of the underlying infrastructure that runs their servers. They can detect the patterns that indicate cryptocurrency mining without having access to the processes, without having any visibility into the memory or the network traffic or anything. So it's a really powerful piece of tech to have access to. So obviously you don't want to have all your cloud infrastructure directly sat on the internet so anyone can access it. If you've already got a VPN in place that gives you like a static IP to exit from, it's a totally sound strategy to restrict your cloud infrastructure to have access only to that IP. If you're going to do this, make sure you enforce 2FA. It's really important to keep your VPN box patched, and don't forget to remove user accounts from it when people leave as well. But I will say that it's not the best option to deploy now if you don't have anything in place at the moment. And there's a few reasons for that. So VPN providers don't have a great track record at security, and this is a really critical device for security. So in the last year alone, Fortinet, F5, Pulse Secure, Palo Alto, all the major vendors for this have had really serious problems with their VPN products. And these are really heavily exploited by actors of kind of all skill levels. It's quite common to see this. They're also not great if you're a small company that's fully remote. If your staff are quite geographically distributed, realistically, you're probably going to end up needing to deploy multiple VPN boxes in different countries, which is really quickly kind of balloons and multiplies the cost and the maintenance budgets for them. And then finally, the kind of operating model of a VPN kind of just isn't really that good anymore. It creates a gateway where basically once you've authenticated with it, anything behind that is fair game. You've authenticated once, you've kind of got access. You're behind the castle walls at that point. But nowadays, you should really be looking to control and restrict access on a more granular level, which is where the alternative comes in. The alternative is kind of at the peak of its hype cycle right now, so there's some truly insane vendor marketing about it. But as long as you can kind of dig through it, there's some really solid options available in the space. Essentially, the idea is that instead of authenticating once and getting access to everything, like a VPN does, nothing is trusted by default. So every request gets authenticated. Users and devices need to authenticate themselves to your identity provider before they're allowed to do anything at all. I'm using Cloudflare as an example here because they've got a particularly mature offering, but the kind of concepts apply regardless of vendor. The kind of identity broker that you pick authenticates you like you'd expect, but then it can also check things like whether your device is fully patched and whether you have up-to-date anti-malware and things like that. So basically we've gone from the VPN model of you're allowed because you're coming from the right place to making a decision using multiple different pieces of evidence and making a dynamic decision about whether to approve or deny based on that context. So if you're going to bring in some kind of secure networking solution to a high-tech company, this is definitely a reasonably early stages technology that's worth looking at introducing. So, to begin wrapping up, use the things that I mentioned here as the basis to create your own security roadmap for the problems that your organization has. You're there to be the expert, so it's on you to work out what's actually needed and what's a nice to have, and you want to be sure that you can justify everything on your roadmap in a way where it makes sense to the business. You want to work out who can sign off on it, who's going to have you the money to pay for it, which might not always be the same person. So you should be prepared to have like a few rounds of kind of reprioritization and iterating to get to a state where everyone's happy with it. And then finally, once you've got it signed off, make sure that you communicate it openly to everyone who could be affected by it. Hopefully you'll have a lot in there that's come from solving other teams' problems and people will be happy with it. But it helps adoption and it helps people be on board if you're transparent about what you're doing and why you're doing it. Because for most people, it's then easier for them to support it if you do so. So, finally, make sure that everything you're thinking about doing, you consider in the context of your business. Not every cyber crisis is truly going to have an impact on what you're doing, so make sure you don't go too hardcore too quickly. Take care of the basics and have a strong foundation to build on. If you're proposing new controls or things that need money spent, you have to be able to explain the business impact of that. It's not enough to say that you want to roll out YubiKeys because it's good for security. You need to be able to explain the consequences of not doing that, what impacts it could have, and why that would impact the continued success of your organization. And then finally, put users at the center of everything that you do. Don't treat them like idiots. Don't tell them no every time they ask to be able to do something, because if you do, they won't stop doing bad things. They'll just stop telling you about them. Your job isn't to be the kind of master keeper of everything that's secure or not. It's to enable everybody else to do their job in the most secure way possible. That's me. Thanks very much. I think we have very brief time for questions.
Yeah, a couple of parts to it. Do you perform any benchmarking with security capabilities? If so, do you know what standard like CMMI? And how do you decide what's the priority?
Great set of questions. So the first part was about do you benchmark your security team's capabilities? And the second part, I've already forgotten. It was about how do you prioritize things?
Standardize like CMMI?
Yeah, not yet. Like I say, that's kind of something that is a more mature process than where we are right now. So yeah, that's something that you'd like to get to, but we're not there yet.